One lever, and that is all it takes. Pull it, and two pneumatic clamps come down simultaneously, holding the aluminum extrusion firmly in place on the table. Push it back, and they retract, clean and instant, ready for the next piece. But it was not always this simple, and to understand why this matters, I have to take you back to where this all started. When you work with aluminum extrusion, drilling is unavoidable, and the reasons are many: blind joints, internal connections, and a whole lot more. Almost every build requires holes to be drilled, and they need to be drilled precisely, in the right spot, at the right depth, every single time. And every time a piece needs to be drilled, it has to be secured first, because that is non-negotiable. A workpiece that is not properly clamped is a genuine safety risk. The drill can cause it to shift, it can slide off the table entirely, and the bit can catch, snap, and damage a piece of extrusion you have already cut to size. My solution for years was the F-clamp, and it always took two of them, every single time. Position the extrusion on the table, place the first clamp, tighten it down, then the second clamp, tighten that clamp too, and only after that then can you drill. When the hole is done, loosen the first clamp, loosen the second, walk them back to the rack, pick up the next piece and repeat the whole thing all over again. And honestly, it works, and there is nothing wrong with it. But when you are processing many pieces in a single session, the repetition adds up faster than you think, and the interruption to your flow adds up just as fast. Every time your hands leave the work to handle a clamp, your momentum breaks. And in a one-man workshop, momentum is everything. So I kept thinking, there has to be a way to eliminate this entirely, and let a machine handle the clamping for me. And that thought became this build. The concept is straightforward, and it starts with two pneumatic press units mounted onto the MFT Centerpiece Assembly Table for the duration of any drilling session. If you have not seen my MFT Centerpiece Assembly Table video, I will link it in the description below, because that table is the foundation of a lot of what happens in this workshop, and it is clearly the main reason this entire pneumatic project works as cleanly as it does. The dog holes machined precisely into that table surface are what allow every press unit to be positioned and locked without any guesswork, and without any permanent modifications to the table at all. Each press unit consists of one pneumatic cylinder, housed between two custom-cut birch plywood panels that form the supporting structure, and below that, a precision-machined aluminum block anchors the entire unit firmly down onto the table, forming the base and another from the top to secure the pneumatic cylinder in position, pointing it down. When activated, the cylinder shaft extends downward, pressing a custom contact foot onto the extrusion below, and that contact foot is 3D printed with a silicone pad bonded to the tip so it holds the workpiece firmly without leaving a single mark on the surface. Both units are triggered by a single manual lever valve. Pull it, and both come down together, push it back, and both retract at the same time. The placement is deliberate, with one unit at each end of the workpiece, and in most cases, two presses are more than enough to hold the extrusion firmly in place. When a drilling session is complete, the entire setup comes off the table and goes into storage, ready to be deployed again for the next session. No permanent modifications to the table, and no dedicated space taken up between sessions. Clean, modular, and practical. To make this work, certain components had to be custom-made. The aluminum blocks, machined to precise dimensions, and the birch plywood panels, cut to the exact profile needed to cradle each cylinder correctly. Beyond those, the remaining hardware was sourced off the shelf, fasteners and fittings that drop straight into the dog holes on the MFT table surface. Now, the plywood parts are large, far too large for a desktop CNC machine, but the aluminum blocks, those were a perfect job for this machine. This is the Makera Carvera Air, and Makera sent me this unit, and in exchange, I committed to making this video. No script, no restrictions, just my honest experience using it for the very first time. And I do mean the very first time, because I have never operated a CNC machine before this project. I did not know the software, I did not know the feeds and speeds, and I honestly did not know what to expect when cutting metal on a desktop machine. Fortunately, I did not have to figure it out alone, because this is Iskons. Iskons is a maker and fabricator who works with large industrial CNC machines. And when I brought this project to him, he stepped in immediately. And without him, none of what you are about to see would have been possible. The Makera Carvera Air is a desktop CNC machine, compact enough to sit on a workbench, enclosed for safety, and designed to handle a range of materials, including aluminum. And that last part is what mattered most to me, because aluminum was exactly what we needed to cut. We loaded the machine with the design files, set up the first block of aluminum, and these are salvaged material from previous aluminum projects, so nothing really goes to waste. And we immediately got to work. And what happened next was not entirely smooth, but that is the honest story, and I'm going to tell it to you exactly as it happened. Aluminum is unforgiving, and I say that with respect. Cut too fast, and the bit overheats and snaps. Cut too slow, and the material work hardens, which also destroys the bit, and the window of acceptable feeds and speeds is narrow, so finding that window costs bits. And we went through several of them before we found the right combination. Each broken bit was essentially a data point. Too aggressive, back off, try again, adjust the depth of cut, adjust the feed rate, run a test pass, and evaluate. Iskons drove this entire process, and his years of experience with industrial machines gave him the instinct to know exactly what the machine was telling us. The sound of a healthy cut versus a cut that was about to go wrong. And when we finally found the sweet spot, the difference was immediate. Clean chip evacuation, consistent cut depth, and the Carvera Air working exactly as it should. The aluminum blocks came out precise, with sharp edges, clean faces, and accurate dimensions. Exactly what the design called for, and for a desktop machine cutting salvaged aluminum blocks, that result genuinely exceeded my expectations. While the Makera handled the aluminum, the birch plywood panels were cut on a completely different machine, because Iskons runs a large industrial-grade tool changer CNC in his own workshop, and that machine cuts through birch plywood without breaking a sweat. The plywood panels that form the housing for each pneumatic cylinder were cut on that machine, because they are far too large for any desktop CNC, including the Carvera Air. And between the two machines, every custom-cut part in this build was fully covered. The remaining components were sourced off the shelf: the pneumatic cylinders, the fittings, the airlines, and the manual lever valve that triggers both units simultaneously. Standard parts, proven parts, and nothing exotic. Except for one: the press foot. My original intention was a full metal press foot, a stainless steel part with an M12 threaded hole through the center, designed to thread directly onto the pneumatic cylinder rod. I sourced the part, it arrived, and the thread pitch was wrong. M12 was correct, but the pitch was not 1.25 millimeters, which is what the pneumatic rod requires, and the part looked right, it measured right, but it simply would not thread on. So rather than hunt for a replacement part with no guarantee of finding the correct pitch, I did what made more sense. I opened Shaper 3D, modeled a custom press foot from scratch, and printed it. I made 3 pieces, with one for spare, with the threads already created in the hole, and brought them to the workshop to test. And yes, I made modifications to the initial design to fit the silicone pad. The 3D printed part fits perfectly onto the M12 rod, and a silicone pad is bonded to the contact face at the bottom, because that is the surface that touches the aluminum extrusion during a press. Soft enough not to scratch, but firm enough to hold. And sometimes the right part simply does not exist, so we have to make it. And in the case of this project, most of the critical parts had to be made from scratch. With all the parts ready, it was time to put everything together. And it starts with the aluminum base blocks going down first, sitting flat on the MFT table surface, located precisely using the dog holes, with no drilling into the table and no permanent modifications whatsoever. The birch plywood panels mount next, forming the housing that cradles each pneumatic cylinder, and the second aluminum block is secured from the top, locking the cylinder firmly in position between the two. But before we can put on the cylinder, the assembly must be fully secured first, and this is safely and easily done with one MFT clamp, holding everything firmly onto the tabletop while I work through the build. 4 M6 bolts will be used to mount the pneumatic cylinder onto the setup, and all the airline connectors will be pointed to the back so they do not get in the way of the action happening up front. After that, one unit is complete, and to lock it down to the table, these large bolts, washers, and nuts will be used, going through the MFT holes. And what's the last item? Yeah, you guessed it right, the press foot. From there, the air lines are routed between both units and connected to the manual lever valve. And this is really the component that ties the entire setup together, because it is one lever controlling two cylinders moving as one. The press feet thread onto each cylinder rod, hand tight and checked, with the silicone pad facing down. And when both units are on the table, the air line connects to the workshop compressor. And for the very first time, the setup is live. 2 units, 1 lever, and everything moving in unison. And honestly, this is the moment the idea stops being a drawing on a screen and becomes something real. And this is what it looks like in practice. The extrusion goes on the table, the lever is pulled, and both clamps come down simultaneously with consistent pressure, locking the workpiece in place. No reaching for clamps, no positioning, no tightening, just drill. When the hole is done, push the lever back, the clamps retract, the piece comes off, and the next one goes on. And the rhythm is completely different now. There is no interruption, no break in focus, and the hands stay on the work where they should be. What used to require 2 F-clamps, 2 hands, and multiple steps is now 1 lever and 1 second. And because the press feet are silicone-tipped, the extrusion surface is protected throughout, so no marks, no scratches, just clean, held, and drilled. The F-clamps are still in the workshop, but they no longer run the workflow because that job now belongs to this. If you are considering the Makera Carvera Air, I will leave my honest summary here. It is a desktop machine, and it will not replace an industrial CNC. But if you have a project that requires precise cuts on aluminum at a scale that fits a workbench, it is capable. We pushed it, we broke bits finding its limits, and when we found the right settings, it delivered clean and accurate results. And for a first-time CNC user working with a machine I had never touched before, that outcome honestly speaks for itself. The link and promo code for the Makera Carvera Air are in the description below. The full design file for this pneumatic press setup, including the 3D models, cut lists, and dimensions, will also be available on my website. Subscribe if you have not already, because every build on this channel is designed, filmed, and put together with the same level of care you saw in this video. This is the Aluminum Carpenter, and I will see you in the next one.